All right, in this section, we're going to take 2.4 and break it up into 3 different days, okay? But we're all solving inequalities. Today is just basic inequalities. The next day will be absolute value, and the third day will be rational inequalities. So basic inequalities, these are less thans and greater thans. So let's look at example 1. 4x plus 7 is less than 3 plus 2x. So the name of the game is combining like terms, guys. So I'm going to start by moving my x terms to this right side. So I'm going to subtract that 2x over here. That gives me 2x plus 7 is less than 3. I'm going to move that 7 over by subtracting it. So I'll have 2x is less than negative 4. Divide by 2. So x is less than negative 2. It says sketch the solution on a number line. So what would I do? I would put negative 2. It's an open circle because it's just a less than. It's not an or equals to. And I would shade like this. And it would be good practice for you to begin writing these in interval notation because that's coming. And make sure you put parentheses on both ends because it's not a closed circle. Let's try another one. Number 2. All right. First thing I would do is get rid of those parentheses. So let's distribute. 2x minus 2 is less than, that's a 3x plus 7. Okay, again, I'm going to move my 3x over here by subtracting it. That gives me negative x minus 2 is less than 7. Add 2. So I have negative x is less than 9. Now I need to divide by negative 1. So remember, when you divide by a negative number with inequalities, you have to reverse the inequality. This becomes a greater than. So x is greater than negative 9. So there it is in that way. On a number line, negative 9 is here, and greater than would go this direction, wouldn't it? And I would want to make sure I put an open circle because it's not an or equals to. So what would this look like in interval notation? Well, negative 9 to positive infinity is what it would look like. Let's try number 3. All right, this one has a fraction. Don't let it freak you out. It's okay. Let's isolate these variables. Let's get those together first. Okay, so I'm going to move that x over. So 3/4 x minus 6 is less than or equal to negative 7. I'm going to move the constant over here, add the 6. So 3/4 x minus x is less than or equal to a negative 1. Now, don't let this negative x mess you up. Remember, this is a 1 over 1. In order to add fractions or subtract, I had to common denominator. So I have 3/4 x minus 4/4 x is less than or equal to negative 1. So negative 7/4 x is less than or equal to negative 1. What the heck do I do now? Well, now I want to get rid of my fraction. So I want to multiply by its reciprocal. So it's going to be negative 4/7, but I got to do it to both sides. The reason I did that is so these will cancel out, and I'll be left with x. But because I multiply by a negative, I have to remember to switch my inequality. All right, and then multiply over here, I'll have positive 4/7. So x is greater than or equal to 4/7. Now, what does that look like on a number line? Well, just pick a spot and call it 4/7. Since it's an or equals to, I'm going to color it in and shade to the right because that's greater than. So interval notation would say bracket 4/7 to infinity. Okay? Let's jump to number 4. Now this is a compound inequality in the way it's written. You may like it like this, you may not. So if you want to separate this out, that is fine. So here's how it separates. 2x plus 3 is less than or equal to 9. And then 2x plus 3, the only problem is you have to remember to reverse this, is greater than or equal to 1, which is what that thing says in the inequality form. It's just weird because the x is on the right side. So when you separate them out and put your x on the left side of the equation, just remember to reverse that. Okay? Now it just solves like a regular old equation. 2x is greater than or equal to negative 2. X is greater than or equal to negative 1. Over here, I'll have 2x is less than or equal to 6, divide by 2. X is less than or equal to 3. Okay, on a number line, what does that look like? Well, Negative 1 gets a closed circle. A 3 gets a closed circle. And notice what happens. It says x is greater than negative 1, but it's less than negative 3. So it should be an and. So here's a clue for you. When you see the original equation has less thans, think and. Think than. Less than. Because x is greater than negative 1 and less than 3. So this is the way your answer will look if it starts as a less than, okay? So in interval notation, what would that be? Well, negative 1 to 3. Let's try some more. And most of these will be less than, so you don't have to worry about the greater than scenario just yet. All right, this one's kind of messy, isn't it? Let's get rid of the stuff going on in the middle first. So negative 8 is less than or equal to 1 minus 3x minus 6. Or no, plus 6, my bad. Plus 6 less than 13. Combine like terms here. All right, multiple ways you can solve this. If I separate this out, I have negative 3x plus 7 is less than or equal to 13, and I'll have negative 3x plus 7 is greater than or equal to negative 8. And then if I solve, negative 3x is greater than or equal to negative 15. Divide by negative 3, so be careful, this has to change signs. This becomes less than or equal to positive 15, right? And over here, if I subtract my 7, I'll have negative 3x is less than or equal to 6. Divide by negative. So look what happened. It changed. This became greater than or equal to negative 2. Okay, so on a number line, what are we looking at here? We have a 15 and we have negative 2. They're both or equal to's, and you would shade in between. So interval notation would say negative 2 to 15. So all of this is my solution. Let's try one more. Now this one, I know already you're like, it's a fraction, gross. Well, let's get rid of the fraction. So let's just pretend the whole thing has a big bracket and let's multiply through by 3. When you do that, you'll have negative 12 less than, now the 3 in the middle will cancel out. So it'll just be the numerators left. So really, I'm just multiplying these ends by 3 and dropping the fraction. Now I can rewrite 2x minus 3 is less than 12. 2x minus 3 is greater than negative 12. And then we solve, right? So add 3 to both sides. So 2x is greater than negative 9. So x is greater than negative 9 halves. Okay, over here, add 3. So 2x is less than 15. Divide by 2. X is less than 15 halves. All right, on the number line, what are we looking at? Negative 9 halves and 15 halves. These get open circles, right? They can't equal these, but they are between them. So my interval notation would then be negative 9 halves to 15 halves, but using parentheses instead of brackets. All right, hope this is making sense. Try the in-class questions, and we'll check them when you get to class. Good luck.